Demand is the answer to the question, how much of something does a consumer want at a given price? It's going to depend on several factors. It depends on the information the consumer has. It depends on the price of other things. It depends on how much money the consumer has to spend, which is what we call income. It depends on regulations. For example, there might be rules restricting the number of units of a certain good that a consumer could consume, and so forth. So demand is a function of the price of a good, as well as all these other things. So we could write down demand, for example, as this function d of the price of the good P, the price of some other substitute good PS, the price of a complement good PC, and the consumer's income Y. So demand is a function of all these different things. So the quantity demanded, which is Q, the quantity that the consumer demands, is some function of all these various things, right? So it's the price of the good that we're talking about, the price PS of some substitute good, price PC of some complementary good, Y, which is the income of the consumer, and so forth. So let's think about a simple example. Take the Canadian pork market. So this is an example in the textbook. According to the textbook, the Canadian pork market is described by the following demand function. The total quantity of pork demanded in this market is a function of the price of pork, the price of beef, the price of chicken, and the income that consumers have. So expressing Y as thousands of dollars per year. So if the consumer's income is, let's say, $15,000, Y would be 15. Expressing by PC the price of chicken, price of PB the price of beef, which are just dollars per kilogram. And if P is the price of pork per kilogram, the total quantity of pork that consumers would demand in Canada is 171 minus 20 times P plus 20 PB plus 3 PC plus 2 times Y. So let's suppose we know that the price of beef is fixed at $4. The price of chicken is $3.33, and that consumers have income of $12,500. So we could plug in these values for PB, PC, and Y. Y here, remember Y is expressed in thousands of dollars per year, so this would be 12.5. So if we went back to the previous slide and we plugged in Y equals 12.5, PB equals 4, PC is 3 1/3, then we would get this expression. The total quantity demanded would be 286 minus 20 times P, which we express as the demand function for pork, so D of P. So the demand for pork, the quantity of pork demanded at the price P is D of P. So we could plot this, and it would give us what we call the demand curve. So the convention is to put quantity on the horizontal axis and price on the vertical axis. There isn't a particularly good reason to do this. It's just what is convention to do. And it's good to stick to convention for the sole reason of not getting confused when you look at someone else's pictures. But otherwise, there isn't a particularly great reason to go with that convention. So for each different price, so for 14.3, for 4.3, 3.3, 2.3, for all these different prices, we can calculate what the quantity of pork demanded would be. So if we just flip back to this previous slide, I could just plug in a price here, and that would give me a total quantity demanded. I just do 20 times that price, subtract that from 286, and I get the quantity. So when the price is 14.3, we'll find that the total quantity demanded is 0. And similarly, when the price is 4.3, the total quantity demanded is 200. When the price is 3.3, the total quantity demanded is 220. When the price is 2.3, the total quantity demanded is 240. And when pork is free, the total quantity demanded is 286. Right? So if we go back here, if we plug in P equals 0, quantity equals 286. All right, so we've got this straight line demand curve. Okay, so now what happens when the price of pork changes? Well, as the price of pork increases, the quantity demanded decreases. This is what's called the law of demand. So there's a few ways to express this. They're really equivalent. One is to say the demand curve slopes downwards. Mathematically, that amounts to saying that the derivative of demand is negative. But notice what we're doing when we change the price is just to move along the demand curve. We're not shifting the demand curve, we're just moving along the demand curve because as we change the price, the quantity demanded changes. But we stay on the demand curve. Okay, what if other things change? Let's say, for example, the price of other goods or the consumer's income, regulations. Let's say something else changes. Well, that's going to cause the entire demand curve to shift. So let's go back to our pork example. Let's suppose the price of beef increases to $4.60. Remember, it was $4 when we wrote down 286 minus 20p as the demand function. Well, if the price of beef rises, now we're going to find that the demand curve is 298 minus 20p. Right? We just plugged in, instead of 4, we plugged in 4.6, and this is what we end up with. Right? So at the same price, there's a larger demand for pork. So what happened to the slope of this demand curve, though? It didn't change. The slope is still minus 20, exactly what it was before the change to the price of beef. Right. So what this change to the price of beef does, the increase of 60 cents, is that it causes the demand curve to shift. The whole demand curve shifts in a parallel fashion. So if beef, and the story here is that if beef becomes more expensive, then people are going to buy pork instead, because it's a substitute good. Right? So the picture would look something like this. If you increase the price of beef, the demand curve for pork shifts to the right. We go from this demand curve to the new one. Okay, now how do we get a market demand curve? And you've probably seen this before, but let's say we have several consumers, like let's say we have Ann and Bob, just 2 consumers to start with. Ann's demand is described by dA, Bob's demand is described by dB. So at each price, P, Ann demands dA of P, Bob demands dB of P. So what's the total demand? Well, it's just the sum of those two. D of P, the total demand, D of P, total demand is just going to be the quantity that Ann wants plus the quantity that Bob wants. Right, so we just add those two together. So the quantity that Ann demands, quantity that Bob demands, together give you the total quantity. And that's our total demand. So how does that look when you do it graphically? What we're going to do is add up the demand curves horizontally. Remember, this is important. I've had students in the past do this vertically, and then that doesn't actually make any sense. And that's because of the way we've labeled the axes. Remember, price is on the vertical axis, quantity is on the horizontal axis. So let's just take an example. Let's suppose Ann's got this demand curve. Okay? And Bob's got this demand curve. Look at any price above, I don't know what this number is here, but let's suppose you look at any price up here. What's the total demand? Well, at these prices P, any price P above this level, Bob doesn't demand anything, so his demand is 0. So the total demand is just Ann's demand, which is why the market demand is just going to track Ann's demand up to that price. But once we're below that price, we just add together the total demand of both Ann and Bob. So how much is Ann demanding at this price? Well, let's look at Ann's demand curve. Remember, this is Ann's demand curve. And so let's take the price 7. At the price 7, she demands 3 units. Well, how much does Bob demand at that price? At the price 7, he demands 5 units. So altogether, they're demanding 8 units. 3 plus 5 is 8. So at price 7, the total quantity demanded is 8. So we get this point on the total demand curve. Doing the same thing at any price below here, we just add up the total quantities and we get this demand curve.